Hey guys, this is Professor Janacek, and I'd like to talk to you about triple integrals in spherical coordinates. Now, in order to change from rectangular coordinates to spherical coordinates, you'll need to know that x is equal to rho sine phi of cosine theta, y is rho sine phi of sine theta, and z is rho cosine phi. Now let's talk about what those values are. In spherical coordinates, the ordered triplet is of the form rho phi theta. Rho is the radius from the center, the pole, out to the edge. Phi is the angle, if you were looking at the rectangular coordinates, it's the angle from the z-axis down to the y-axis. And theta is the angle between the x-axis to the y-axis. So our value rho, the radius, goes from 0 to infinity. It's only a positive value. Phi, going from the z-axis to the y-axis, goes from 0 to pi, and theta can actually go all the way around from 0 to 2 pi. Now you might be wondering, why does phi only go from 0 to pi? Because if both phi and theta went from 0 to 2 pi, then you would actually be overlapping part of the sphere. And so we have to limit one of them, so we limit phi to go from 0 to pi. Another thing to recall, just like back in cylindrical coordinates and even polar coordinates, dv is a little different. It's not just d rho, d phi, d theta. Instead, and I'm not going to go through the explanation of this, but looking at how the spheres are shaped, turns out that dv is equal to actually rho squared times the sine of phi, d rho, d phi, d theta. So anytime we're going to replace dx, dy, dz, or dv, we're going to have to use that whole rho squared sine phi, d rho, d phi, d theta. All right, let's take a look at an example. Let's evaluate this integral in spherical coordinates. We are given the triple integral over the region B of e raised to the opposite of the quantity, x squared plus y squared plus z squared raised to the 3/2 power dv, for our region of integration being the unit ball. Now I have kind of sketched a graph of the unit ball there. Remember, it's going out to 1 in all directions. All right, so what does this triple integral look like if I write it as an iterated integral? Well, the first thing we need to look at is rewriting our integrand. So that integrand, e raised to this crazy power, let's take a look at that power itself. I'm going to just play around with that opposite of the x squared plus y squared plus z squared to the 3/2 power. Now, if you take the substitution that x is equal to rho sine phi cosine theta, y is equal to rho sine phi sine theta, and z is equal to rho cosine phi, put that in here, square things, combine like terms, factor out, I would actually factor out the rho squared, and recall that sine squared phi plus cosine squared phi is equal to 1, as is sine squared theta plus cosine squared theta. Using those substitutions, you end up getting that exponent ends up being negative rho cubed. So our integrand becomes negative rho cubed. I'm sorry, wait, there's an e. That's e to the negative rho cubed. The other thing to recall is dV. Remember, dV is rho squared sine phi d rho d phi d theta. Right, now that we have that, let's talk about our limits of integration. All right, starting with the inner one, the inside one, let's take a look at rho first. Remember, rho is the radius, and we're looking at the unit ball. The radius goes from 0 to 1. Moving outward, let's take a look now at phi. Phi, remember, this is just a ball, typical sphere. Phi goes from 0 to pi. And finally, theta, all the way around. It's not half of the sphere or just a portion of it. It's going to go all the way around, and so that's 0 to 2 pi. And so now I think we are ready to integrate. We're going to start by integrating with respect to rho. Notice we will need to use a u substitution. And we'll let u be actually negative rho cubed, that exponent there. Let u be that exponent. Then du would include rho squared d rho. Of course, you would have that coefficient of negative 1/3. So when you integrate that, you actually end up getting, take your time with that, make sure you're comfortable with that substitution, you get negative 1/3 e to the negative rho cubed. And of course, we still have sine of phi. So again, notice we're integrating e to the negative rho cubed times rho squared d rho. Just integrate this using that u substitution, which we would write as the integral of that's e to the u du. Make sure you set it up properly and you'll be fine. Again, you end up getting that negative 1/3 as a coefficient. So take your time with that. Your result should be negative 1/3 e to the negative rho cubed. But just a straightforward substitution there shouldn't be too bad. So continuing on, this gets evaluated from 0 to 1, and then we'll still integrate with respect to phi and then with respect to theta. Okay, so we end up with e raised to the negative 1 in the first term and e raised to the positive 1, e raised to the 0 in the second term. Of course, e raised to the 0 is 1, and e raised to the negative 1 actually gives me an e in the denominator. So if we simplify all this down, we end up with negative 1/3e sine phi plus 1/3 sine phi. Again, notice that the e in the second term becomes a 1. E to the 0, that becomes 1, so I don't have an e in that second term. All right, now if we integrate with respect to phi, integrating sine of phi gives us a negative cosine, so we get positive 1/3e cosine phi. And then, let's see, the second one becomes minus 1/3 cosine of phi, which we'll evaluate from 0 to pi before integrating with respect to theta. All right, well, let's see. Cosine of pi is -1. Cosine of 0 is +1. Putting all of that together, combining like terms, what do we get? Looks like we get -2/3e plus 2/3. So if we integrate that with respect to theta, of course, those are all just constants with respect to theta. So we'll keep those there. We just put a theta there behind them. I am going to go ahead and turn this around. I don't want to lose that negative, so I'm going to write it as 2/3 minus 2/3e times theta evaluated from 0 to 2 pi. Which, if I factor out this coefficient here, we end up getting 2 pi minus 0. And let's see, rather than distributing in the 2 pi, let's go ahead and factor out some. I can factor out a 2/3 along with the 2 pi, so that gives us 4 pi over 3 times 1 minus 1/e, which we can write as 4 pi over 3 times 1 minus e to the -1. Ooh, and there we go. All right, got a little tricky in there. Take your time with some of those integration techniques and the evaluation as well, but all in all, not too bad. Enjoy.